Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of direct variation, specifically how we could use it to solve problem situations, and we'll do it in 5 minutes or less. So when we look for direct variation on our reference materials, we will see this y equals kx, which is slightly different than our slope-intercept form. So slope-intercept form is y equals mx plus b, but in both situations here, this k and the m, they both represent, if we were to graph it, the slope, or really it's the constant rate of change. So when we are thinking of the y equals kx, we can think of our k as our slope, if that helps us, even though it's a k instead of an m. The big difference here is that it's directly proportional, which means there is no y-intercept that is different than 0. So if you were to graph something that goes through direct variation, it is always going to go through the origin, whereas the slope-intercept form plus b lets you know that it does not start through the origin. And how we find this k, this constant, is we use this formula, k equals y over x. Remember, so that's the rise over run, so that's just our slope. So let's look how we can use this in an example. So the value of y is directly proportional, so they're letting you know in the word problem right here that we are going to use the direct proportionality, y equals kx, directly proportional to the value of x, and then they're going to give you a few points. If y equals 21.6 when x equals 54, then we need to find the value of y when x equals 78. All right, so if we're thinking y equals kx, they give us a y and an x, but we need that k. So remember, our constant of proportionality is going to be y over x. Right? That's our rise over run, which is really our dependent variable over our independent variable. So they're going to go and give that to us. And so the y is 21.6 and your x is 54. And if you pull out your calculator, you're going to realize that that is simply 0.4 or 4/10. So now we can plug in y equals kx with 0.4 as our k, and our x is going to be 78. And I'm wondering, what is our y when those two are the k and the x? And you're going to see that, once again, pull out your calculator. You'll see that it's going to equal 31.2. So y equals 31 and 2/10. So that's how you would use it in this situation. Let's look at another example. So our new problem situation has the total volume in cubic centimeters the bathtub fills up, varies directly. So we're going to use our y equals kx again with the time in seconds. So the bathtub has a total of 15 cubic centimeters after 6 seconds. All right, so that is going to have to be our y, and our x are dependent and independent. So has a total of, so this is going to be our dependent variable, our y, because the time is what changes. That's our independent variable. And then we need to find the total time in seconds. The bathtub has been filling up when the total volume is 175. So once again, let's find our constant. Right, so we have to identify what is the dependent and the independent variable. So it has a total. That's always a clue that you're going to get kind of your independent, or that's your dependent variable. So that's going to be 15. And then after 6 seconds, that's what varies. All right, so 15 over 6. Right, so that is going to be 2.5. So that's our constant of proportionality. So now we need to find our y equals kx, but they give you the total volume in cubic centimeters. Remember, that is our y. So we're going to say 175 y equals 2.5 kx. So we're looking for this x. Now what we have to do is we end up having to divide both sides by that k, that 2.5. So let's take our 175 divided by 2.5. And we are going to get 70, and that would be our x.